All right, so if you're using uh, this booklet to follow along, this will be on page 17. Just make sure you look for calculating the height of a triangle section. So we're going back a little bit. So in several instances, it will be necessary to determine the height of a triangle. Let's explore this further. So determine the height of the triangle below. So I will highlight that, highlight the height that we're trying to solve for. So let's just use a color that is consistent, right? So if we wanted that side right there, um, we would want to almost consider cutting this oblique triangle, cut it right down the middle. And remember that the height is measured perpendicular to the base always, right? So if you're making, right, if you're creating that height, sometimes it won't be there. That's why it's dashed. It's kind of just wondering like how high is the tallest point, right? So they meet at a 90-degree angle, right? The base and the height. So what we'll do here is split this into two triangles, as I already mentioned. So we're going to cut this like that. Okay. And this is what we will call the height. And the 4.52 follows us. Okay. The 59.8 follows us too. Okay. Like that. And let's find the height of this particular triangle. Now, you might say, well, I can use SOHCAHTOA like last year, but I won't. And I will just basically highlight this side green because there's something I want to emphasize later on. So this side is green, for me at least, whatever color you have. And the height is still the same color. So you see that you have a pair there which calls for sine law, right? So we're going to go sine of 90 degrees over 4.52 is equal to sine of 59.8 over the height. Okay? So this also, sine law also works with a right triangle, as you can tell. So this will be cross multiplying, right? We cross multiply and divide. Divided by sine of 90. And I want to get it out of the system right away. Try sine of 90, you will get 1, right? So it's almost like you're dividing this by 1. So it's not really necessary. Okay, so we're just going to basically focus on 4.52 times sine of 59.8. That's 3.91. 91. So there we have it, and that's in feet. So we technically found the height of this triangle, which doesn't change, right? Like once you determine this, it should be the same even if you were to approach it from this side. But I am actually going to do it because I need to just see it. Almost like proving my point here. Notice that the 8.2, which was the base, we could not transfer because, right, we're dealing with a part of this big triangle. So let's cut it out here. Make it a little bit longer. Okay, so it's still on 90. This is still my height. This is 7.1 feet, and this is 33.4. Right? I drew this to scale, right? And let's go ahead and do the same thing. So the height is still the same color, and here I'm going to use orange, just like I did on my original, like that. And so here you have your pair. And by the way, you can always find your height like this by making your right triangle, cutting it. But I will show you a shortcut after this example where you can just quickly figure out the height of a triangle if you just have the right pieces of information. So sine of 33.4 over height, right? So notice, right, this expression looks quite different, except for the sign of 90, right? It looks different, but you'll find out that you get the same answer. So 7.1 times sine of 33.4 divided by sine of 90, which we know is 1. Okay, so 7.1 times sine of 33.4 divided by 1, that's 3.91 still feet. Right? So you've determined the height of this triangle approaching it from both sides, because quite frankly, you had more information than what you would normally get, right? So I will just go ahead and highlight these two, figuring out that, hey, we found the height. And notice that the key thing is, I'll just give you a little observation here already, the angle, and you need the side touching that angle, right? Look at this, 7.1, which is that orange side, times sine of 33.4, where my finger is, right? So we took this side and multiplied by sine of that angle. Whereas on this side here, we used, if you follow my finger, 452, which is this green side, right, is multiplying the angle adjacent to it, sine of 59.8. And so basically that's how you find the height. Okay. This also works if this were flipped upside down and you wanted to find the depth of something, it's still the same. Or the width of a river, let's say, if this is flat, laying down flat, but we're still applying the exact same skill. Okay. So here we go. Here is my conjecture. My final statement here is that the height of a triangle is taking the side length times sine of the adjacent angle. Okay, so how does this work? Let's label all these triangles. I'll just give you 3 different scenarios that you can possibly encounter. So this would be R, P, and this is Q, right? This whole thing here. Let's take this triangle, capital D, so this is lowercase d, lowercase e, lowercase f. And we take this one, look at the height is not even inside the triangle, it's outside the triangle, right? That's also a scenario. So you have P, R, and this is Q here. So one thing that I always want you to remember, right, is if you, for example, wanted to know the height of this triangle and you know this side and the angle that's adjacent to it, just go R times sine of P, that will give you the height. Okay. So in this case, you would, to find the height, we would just go side R times sine of angle P. I will use highlighters in a bit, right? That's if you come from this side. If you came from this side of the triangle, we would actually take P, this slanted side, times sine of angle R, right? Or H would be P, right? Lowercase p, times sine of angle R. Right, so I'll use the green and the orange just like I did before. Right, so here's the green side, right, and that's green. And then this other one, right, this side here, P, right there. If you look at it later, you can see it. Hey, it's like, oh yeah, I see what's happening there. And same thing over here. If you wanted to talk about this triangle here, to find the depth in this case, if you use this slanted side here, side E, you would want to multiply it by angle D, right? So not just angle D, that is sine of angle D. Or to find the depth, if you wanted to come from this side, let's say they gave you this side, we would take, oh, there's 2 D's there. We have to go depth. is side D times, right? So side D times sine of E, just like that. And I will do the same thing again. I'll make this side green, right? That was our side E. And this side is D, right? It stands out a bit more. So there you have it. So there's two ways to find the height. Notice that we don't use the base, right? The horizontal line in this case, we don't use that. So for this particular case, if you wanted to use R, right, this, you'd multiply it by sine of P. So to find the height of this triangle, you take side R times sine of P. Or to find H, if you want to use this side, side P, you would multiply it by sine of R. Okay. There again, let's do the same thing. Green, green. Orange, orange. I don't know if you have more highlighters. I do have I have a pink one and maybe a blue. I have a blue here. If you want to, if you can, right? This angle here is that angle there, right? So there you can see that, right? Blue and green are together. Same thing here. I would make this angle blue, right? So angle D is right there. So blue and green kind of go together. And I would make this the blue one here. So you have that. And then I'm going to use the pink one, right, to emphasize that that's angle R. E. This is angle R here. So it's very colorful, but then that way at least you see it. All right. So really, you just need one version of these maybe, and then you should get the point there. Okay. All right. So let's keep going. I want you to now, knowing this, or maybe the this part right here should definitely be highlighted. Overall, that is very important for everything we do whenever it comes to finding the height or the depth. Like let's say there's two ships here and they spot something under the sea level. How far down, how far below the surface of the water is that particular object? This will come in handy, right? Knowing how to find the height. So I want you to practice that. Go to page 18 here. And I want you to practice that. I will actually just get you to focus. It says calculate the length of the indicated side. So there's a certain side you're supposed to solve for. So I want you to do that. And then afterwards, I want you to find the height as well. The height of each triangle. So for this particular one, the height would be to the highest point there. So it's right here. You can use dashed lines there. So the height is here, right? In this particular one, the height is actually inside. So hey, what's the height there? But do that afterwards, okay? And here, this one is a little slanted, but we're gonna say we want the height right there. Okay, that's what we're gonna say. So I want you to figure out those, and then we'll move on. So I want you to work on this whole page here. So on page 18, and as I mentioned, and once you're done this, you know what? I'm just going to tell you, maybe just to prove the point, just focus on finding the height of all of these. Don't solve for the indicated side, okay? just solve, because it's sine law. Most of them are sine law, so I know you know how to do that. So just determine the height of these triangles here on page 18. This one I do want you to solve. There is a way of doing that. Just watch what kind of triangle it is. Okay, it actually has everything you need to solve the triangle, and try to fit that in here. You should be able to do it. It's actually not that bad. And then I want you to go to page 19, right? And try page 20 as well. So these all have something to do with the height, right? How high up the pole are the wires attached and stuff like that. So I want you to be able to do that, as well as page 21, where there is another one involving a height. Okay, so all the way to page 21. If you weren't here for cosine, or if you still need to catch up with cosine, if you go to page 26, right, these are pages that I would strongly recommend you do. Page 27 to 28 on this booklet, where you basically draw and solve. That key should be posted. And then pages 29 and 30, you're calculating the area of a triangle. And remember, to find the area of a triangle, you actually need to know the height. Okay, so that'll be part of what you need to know. So practice, make sure you practice and you know how to do things. And once you go to page 31 and on, these are just basic, like solve the triangle scenarios, so you can practice your cosine law and sine law. And the key is on page 34, right? There you have your key for that. So basically, everything up to page 34 is you should be able to do, okay? Including what we just learned now with finding the height. So I will post the key to that. And if some of it is missing, that means that I want to go over it on the next class. Okay. Thank you.